Yes friends, now let's understand one more example related to that auto boxing and auto unboxing. Observe here, what is that code? Simple code. And if you do understand the code which I am going to write now internally in depth, I am sure that no confusion will be there for you in lang package as well as in collection framework. Okay, you can be very comfort in both the concepts. Okay, observe, let me take a class called A. Okay, now observe here, public static void main string array. I have said one thing to you, all our wrapper classes are child to one class called number abstract class. Okay, number abstract class. Okay, float, double, and other one is what? Long. Okay, all these classes are what? Final classes. All these classes are what? Final classes. And within each and every class, even in boolean wrapper class and also in character wrapper classes which are child to object but not child to number class. These are the classes which are child to number class, which is an abstract class, and character and boolean are the wrapper classes child to object class but not to number class. Okay, now even these two classes are also final classes. Okay, one small thing, within all these wrapper classes, hash code method and equals method has been overridden to avoid duplicates within hashing related data structures. Okay, to avoid duplicates within the hashing related data structures. Okay, within hashing related data structures. Okay, what is that? Hash code method and equals method has been overridden within both the within all the wrapper classes to avoid duplicates within hashing related within the hashing related data structures. Okay, hashing related data structures. I am going to use this knowledge, please observe, and you will get very good clarity about hash code method present in a particular class and hash code method available within a class called object. Within the class called object, we are having one public native int hash code method. Okay, now I hope you can differentiate these two methods execution or these two methods call by JVM at runtime, how it is going to call. Okay, I am going to differentiate both of those things. Now observe, so one small thing, all these classes are what? Final classes, and in all the wrapper classes hash code method equals method has been overridden, and all these classes are immutable classes. What are these? Immutable classes. Immutable means what? Non-adjusting class. Okay, non-adjusting class. Okay, what is non-adjusting class means? If I have one string object s equals to new string of Anil. Okay, now what happens because of this one? Because of this one there will be string object. Yes, with content as what? With content as what, friends? There will be char array value with data as what? Anil. Okay, with data as what? Anil. If you are not getting this representation, how this fellow is writing, if you get such type of doubts, please refer string class argument constructor. Internally the memory representations will be in this form only. Now observe, s dot concat of Raju. What is this method implementation? It will append the old object data by using argument data within new object, because if this method is trying to this method, observe here, this method concat method is having logic to create a new object, okay, and within that object this concat method will access old object data and it will append this data. Getting? Observe here, I have informed to you one thing, we are achieving non-adjusting nature because of methods logic, because of not objects. You have to remember this one, okay. What is that? Immutability in nature you are achieving because of methods implementation only. Getting? Within this method you are having creation of new string object. Such type of code is available internally, but not through object. Of course, string is what? Immutable object, that is non-adjusting object. You are getting this ability to objects through method implementations, but not this object is having some other behaviors. No, please understand, you are achieving this one because of method implementations. All methods will simply go and create what? New objects without any reusing this object, okay. If there is any small modification within the object data, simply they will create a new object of a string and they will write this data, that is new data, resultant data within new object. That is why string objects are become as immutable. Getting? Because of methods implementation, string objects are immutable. Immutable means what? Non-adjusting nature. Now these methods are not allowing this object to have some modifications. Please object, you don't worry, I will do those modifications within the new object. Like that this concat method is telling by having its own implementation. I hope you get this one, okay. What is that? Still now what we have discussed, all the wrapper classes are final classes. Getting? And all wrapper classes has overridden two methods, hash code method, equals method, in order to avoid duplicates within the hashing related data structures, okay. Now this character and boolean classes are not child to number class, they are child to directly object class, and within the object class we are having one hash code method whose return type is int and which is native method, okay. Now you will get good clarity how JVM is going to call specific class hash code method and object class hash code method now through this example. And these wrapper classes all are immutable classes. What is immutable? Simple thing, immutable means non-adjusting nature. What is this non-adjusting? Observe, I have taken one string s equals to new string Anil. Now within the string object the data will be available in this fashion. Internally, because of string class constructor, this will be the memory representation by our JVM. Now if I call s dot concat, observe here, because of method implementations only we are achieving immutable nature. Immutable means non-adjusting nature. Okay, now what is that means? These methods will create a new object by accessing old object data, and they will append some other data, and they will write that resultant data as new object data. So because of these methods logics only, we are achieving immutable nature to our wrapper classes and also to the string classes. Okay, even in wrapper classes, like our concat method within string class, like our concat method within the string class, our wrapper class methods, okay, our wrapper classes are also having methods. Wrapper classes also having methods to create new object for any modification. Okay, that is what immutable nature. Okay, immutable means non-adjusting nature. Okay, now observe, come to this point. Okay, come to this code. Okay, let me take a class called A. Okay, now take public static void main string array. Now I'm going to create an integer object by using AutoBoxing concept. What is AutoBoxing concept? The process of converting primitive to the wrapper object, that is wrapping a primitive data to the object. Observe here. Now what is happening because of this one? I'm wrapping 9 within the object of type integer, which is referring with I1. Okay, which is referring with I1. This I is wrapped within the object. Okay, now observe. Now can I yes, now observe, this is very important to me. Okay, now observe, whatever the object which is going to create within at our Java, whatever object which is going to create at our Java will have address. Okay, will have what? Address. That address will be ranging from 00 to 0xFFF. For each and every segment of our RAM, you will have this address. Okay, now let us take any one random address 0x0009, and this address, observe friends, this address getting approximate integer value will be hash code. Approximate integer value is what? Hash code. Observe here, approximate integer, approximate, right? Not exact value. Approximate integer is what? Our hash code. This hash code will be generating by object class hash code method. This is very important to us. Okay, by object class hash code method at the time of object creation. Okay, now observe, either this address or this hash code approximate hexadecimal string value is called as reference value. Either address or hash code approximate conversion to hexadecimal string value is called as reference value. Let it be approximate value, right? Let me put 0990F. Hexadecimal range is what? 0 to 9, A to small f, or capital A to capital EZ. Okay, so I have taken that number, any number guys. Okay, any number. So let me take simple number. What is that? Let it be 1A. Let it be as what? 1A. Okay, let that be as what? 1A. Okay, now observe here. So here what will get happen? Auto boxing, getting auto boxing, meaning is what? This statement will be replaced as what? This statement will be replaced as what? This statement will replaced as what? Integer dot value of I, that is 9 or else 9. Okay, so this will be the compiler generated code. It is compiler generated code. About this we have understood. I hope you get this one. Okay, now within this value of method you are having logic to create this object. In which way? New of integer of I, getting I value is what? 9. Okay, so now new object has been created. This object type is what? Integer. Now observe here. Now observe. Now observe. Now observe. Now what is happening here? This 1a I am copying to I1, this 1a I am copying to I1. So I1 is there one variable whose value is what? 1a, because of assignment operator. Now observe, 1a both are same. So from this person I can reach this address. So let me put one arrow mark. Okay, so observe here, because of auto boxing, here you will have one code. What is that? Integer dot value of I. So within this value of method you will have the code to create an object. Okay, new followed by constructor will be available. Okay, now observe here. Now for each and every object address will be there, and that address approximate integer value is what? Our hash code. Who will generate that hash code? Our object class hash code. Native hash code method will generate that hash code integer value. Okay, now this address or hash code approximate hexadecimal string value is our reference value. This is what? Our reference value, and this I1 is called as reference variable. Okay, reference variable. Okay, now observe. Now can I assign I1 value is what? 1a. Now what is I variable value? I variable value is what? 9. I1 variable value is what? 1a. I variable value 9. I1 variable value 1a. Now I1 I am assigning to integer of I2. Now observe here what I am doing here. I observe here, this is what? Declaration, and this is what? Initialization. Yes or no? Yes, this is what? Declaration, this is what? Initialization. Int I, declaration, later initialization. Okay, declaration and initialization. Okay, now observe. Now observe here. Okay, now observe here. Now what is I1 value? 1a. 1a I am assigning to I1. First declaration has been done. So here I have I2 variable. I2 variable will contain the data as I1 variable data, because assignment right here. Yes, initialization. So now here I'll have the data as 1a. Okay, now I2 variable value is what? 1a. 1a is the identity or reference value to this object or not? Yes. From this person can I reach this area? Yes, we can reach without any restriction. So let me put one arrow mark. Okay, just for our future reference. Okay, now friends, observe here very carefully. Okay, now okay, now I1 dot, observe friends, I1 dot int value. What this method will do? What int value method will do? This method is having logic to convert. This method is having logic to convert a wrapper object data to primitive int. Getting? This is what? Integer wrapper object data that I am converting to int, that I am converting to the int, friends. Okay, that I am converting to the int. Okay, now I1 is referring one object whose data is what? 9. I'm sorry, I forget to put this 9 here. Okay, so I1 object data value is what? 9. Okay, now it will convert this object data to the primitive int. Okay, it will convert this into to the primitive, this 9 to the primitive 9. Now observe, friends, plus 90 plus 90. Observe, friends, plus 90. Now what will be the value? Resultant value plus 90. Resultant value is what, friends? 99. 99. Now observe here properly. This is what? Primitive value. Now what is I? Primitive variable int. Instead of I at runtime, here it will be as what? 9. 9 only converting to the object. Primitive converting to the object type. AutoBoxing. This is what? AutoBoxing code. This is what? AutoUnboxing code. Okay, now observe here. Let me assign these to one integer integer variable. Of course, let me assign this one to let me assign to I. Let me assign this to I1. Okay, let me assign this to I1. Now I have one small doubt. Mister, what will be the I1 value? Okay, now SOP of I1, SOP of I2. What will be the values of I1, I2? That's it. Okay, this is what the question here. Okay, this is what the question. Okay, what is that? Value of I1 and value of I2. Okay, value of I1 and value of I2. Observe here. 99 you are assigning to one I1 variable. Type is what? Reference, that is class type, integer. Meaning is what? Converting primitive to the wrapper object. Now here the compiler will put one code here. I mean here the JVM will do one thing here. Okay, here the JVM will do one small thing. Observe here. So here JVM will do one task. What is that? Assigning primitive to the reference variable. So definitely here there should be AutoBoxing or not? Yes, there must and should be what? AutoBoxing. Okay, now here if you do run and compile and execute this piece of code, what will be the answer? Simply double line, simply 9 will be the answer. Simply double line and 9 will be the answer. If you want to check, you can check this one. Observe here, I have taken one class A and here I have taken one primitive variable and one integer variable, that is reference variable I1. To that I am assigning I, that is I am performing AutoBoxing. And here I have taken assignment. Okay, here I am assigning I1 value to the I2, and here what I am doing here, I am performing AutoUnboxing and I am adding 90 and I am assigning this value to whom? To once again I1. Once again, what is this? Primitive I am assigning to reference variable, converting primitive to the wrapper object. So here the value will be as what? Double line. Here the value will be as what? 9. Okay, here the value will be as what? 9. Y means observe here. Okay, Y means observe. We have understood we have understood all the wrapper classes are what? Immutable objects. Because of methods only we are achieving immutability. I have said to you at earlier case, string s equals to new string of Anil. Okay, now a start concat of Raju. Now what will be the s value, SOP of s, reassigning s variable value, so Anil Raju will be the output. So in the same fashion here, I have done what I am doing here, method names are changing. Here this concat method, here concat method is having logic to create a new string object. It is having logic to create a new string object. Like that, even in this integer class, all the methods are having, even within the class called integer, all the methods, value of method, getting, all the methods are having logic to create new object. Even what is that int value method, all the methods are having, not int value method, that is a toString method, getting toString method, and value of method having argument as 2 arguments, is having logic to create new object. That's why this integer class is immutable class. Okay, so all these methods are having logic to create a new object, that is new integer object. Okay, now observe here, if I do run and execute, compile and execute, this will be the output. I will give the reason for you why you are going to get this output, and also I will show one small trick here. Okay, first let me compile and execute this piece of code. Okay, what I have taken here, int I equals to 9 and integer I1 equals to I. What I have done later, integer I1, I2, I1 I am assigning to I2, and later what I have taken, I am calling I1 dot int value plus 90. Now system dot out dot println of I2 comma I1. So answer is what? 999. Okay, observe here. Okay, let me compile this one. Okay, java c test dot java, this is the source code name, that is test is the source code name. Okay, now what is the main method? Class name capital A, so let me put capital A. So answer is what? 999 is the answer to us. Okay, 99 and 9 is the answer. Okay, observe here. But how we are getting that? How we are getting that output? Simple, dead simple. Observe, dead simple. Observe. This is what? 99. I said that value of method having single argument is having logic to create a new object. Here also having logic to create a new object. Okay, having logic to create a new object. Now observe here. Here I am assigning a primitive to the reference variable. Now what this concept is calling? Converting a primitive to the object type. Getting? So that is called as AutoBoxing. AutoBoxing means this method will be called. Okay, this method will be called. How it will be called? How it will be called? Integer dot value of I1 dot int value plus 90. In this way it is going to call who? Our compiler. Now JVM will simply come and executes this particular method. Now value of method is having what? Logic to create a new object. Now observe here, a new object will be creating with the data as what? Double 9. Observe, with new object data as what? 99. Each and every object is having what? Address 0x00, let it be 8. It's it's approximate integer value. First time observe, approximate integer value is what? Hash code, let it be 7272. Approximate value is called as hash code. Who will generate that hash code first time? Very specific thing, by our object class hash code method. I will prove all of these things. Okay, I will prove this one. Okay, now either this and this hash code approximate hexadecimal hexadecimal string value is reference value. Okay, now let it be 2a. Now this 2a we are assigning to I1. I1 type is what? Integer. Yes or no? Yes, integer. Now 2a we are assigning to I1. I1 value I am reassigning. Observe here, can I assign like this? Int I equals to 99, or else if you are getting confused, just 0. Can I assign I equals to 1? Yes, 1 I am assigning to I. After some lines of code, 1 I am assigning to 1 assigning to I. So at this statement I variable value 0. After some lines of code, I am reassigning I value to 1. Okay, in the same fashion it is happening here. Now 2a, this value of method, what it is doing? It is assigning 2a to I1 variable. 2a, observe, 2a, this is what? 1a, 2a. From this person, which address or which block I can reach? This block only I can reach, mister. This block only I can reach. So not this block, that's it. 2a, that's why I am having the output as what? Now what is there within this object? Now if I pass any reference variable as an argument to system.out.println method, internally what JVM will do, we have understood as part of toString within this lang package. Internally JVM will call toString method. What is there within toString method? toString method is having logic to return the object data. Okay, what is here? Object data 99. So that's why 99 we are getting as output. And here I2 still referring value as what? 1a, so it will refer this object. Now once again toString method, so you will get 9 as the output. Okay, you will get 9 as the output for this SOP of I2. Okay, SOP of I2. Observe here, what I have done, I have taken one class A with one primitive variable and I assign that primitive variable to one reference variable I1. So here internally compiler will do AutoBoxing code. What is AutoBoxing code? Calling value of method with primitive variable as an argument from the integer class. Because value of method is what? Within the integer class, it is what? A static method. Static method public. All are what? Some are instance and some are static methods having return type as what? Integer. All are what? Public static integer. Okay, that is value of methods. Okay, now so here you can call by using class name. Okay, now here AutoBoxing will get happen because of AutoBoxing, because of value of method. What will get happen within value of method? What is the logic to create a new object? What is the logic within value of method? It will always create a new object with parameter as data. It will use that parameter as the data. What is here? Parameter I data, I value is what? 9. So that will be the data within the object. Okay, within the object. Now observe, after creating object, this value of method will return reference value, that is reference value. What is that? Observe, for each and every object at our Java there will be address. Okay, and that address approximate integer value is our hash code. Who will generate this approximate integer value of this address? Our object class hash code method. Why I am bringing this one means I will let you know later. Okay, because of object class hash code method, you are going to have here an approximate integer value to this address. Okay, now either address or hash code approximate hexadecimal string value is our reference value. This reference value only, this value of method will return. Okay, value of method return type is what? Integer. Return type is what, friends? Integer. Okay, integer means it will return this integer object reference value, that is identity number. This is the exact meaning. Okay, now observe, that value we are assigning to whom? I1. So I1 value will be as what? 1a. 1a both are same. So I can reach this block or address from this person. So I have put one arrow mark. Now later in the next step, what I have done? I have copied I1 value to one more variable, reference variable. Okay, what is that? I2 variable. So I2 variable value is what? 1a. So I1 variable is what? 1a. 1a I copy to I2 variable. Now please observe, 1a both are same. So I have put one arrow mark here. Okay, now next within this statement, what I have done? I have converted I1 wrapper object wrapped primitive data to primitive, that is called as AutoUnboxing. Okay, this is called as AutoUnboxing or not? Yes. After performing this AutoUnboxing, what I am doing here? I am adding 90 to that primitive value, and that resultant value once again I am assigning to I1. What is I1 variable type? Integer, which is reference variable. So here once again AutoBoxing will be done by our compiler. So if it is doing AutoBoxing means the code will be in this format. Getting, guys? The code will be in this format. Okay, now what? Observe here, within entire value of method this code is available. Okay, now what value of method will do? It will create a new object. That is the logic within within value of method. So after creating a new object, as I said earlier, observe here, each and every object will have address, and that address approximate integer value is our hash code. Who will generate this hash code? Our object class, native method called hash code method. Now either address or hash code approximate hexadecimal string value is our reference value. That value Here you are reassigning to whom? I1, getting I1. So 2a will be reassigned to I1. Instead of 1a, it will have the value as what? 2a. Now observe here. 2a, this is what? 1a. This is what? 2a, and this is 2a. So from this person I can reach this place at this block at this address. So it will not refer this object. That's why how I have put one tick mark there. So it will refer this object only. Okay. Now what I am doing, I am passing I1 reference variable as argument to system.out.println method, and I am passing I2 as an argument to system.out.println. If I pass any reference variable as an argument to system.out.println method, internally JVM calls toString method. Now within this integer class, toString method is overridden to return the it is having logic to return the object data. Now observe, what is I1 referring object? This integer object. What is the data here? 99. So 99 is the output. Okay. Now what is I2 referring object? This object. So 9 is the output, because here I2 dot toString method will be called. I2 is what? Integer object. So integer class toString method will be called. What is logic here? To return object data. To return what? Object data. This is the analysis for this code. Now once again please observe, instead of this if I put I1 plus plus, now what is the output? If I put instead of this one just I1 plus plus equals to I1, think that I have commented this line. Now if I print I1 and I2, what will be the output? Simple thing, still the output will be a different output. Here you will get what? 10. Here you will get what? Output as 10. Observe here. What is this code? This code equivalent expression. This code equivalent expression is what? I1 plus 1. I1 plus 1. Now observe here the same thing. I1 will be converted to the AutoUnboxing, and it will add 9 plus 1, 10. 10 will be assigning to whom? 10 will be, or else at least I will take this one out. I am sorry, this should not be here. I1 should not come here. Okay, it should not be I1 equals, okay, just that one. So what is equivalent expression for this statement? I1 plus 1 assigning to I1. Okay, I1 plus 1 assigning to I1. Now what happening here? 9 plus 1, what is that? 10. 10 assigning to I1 variable, reference variable. Once again integer dot value of method will be called. So here you will get output as what? 10, 9. Observe here, instead of here 99 you will have the data as what? 10. Okay, observe. Let me compile and execute this one. Just a minute. Okay, observe here. Okay, observe here. Now what is that? Let me comment this one. I1 plus plus. Now if I print I1 value, 10 is the answer. Okay, let me compile this. Let me run. 10, 9 is the output. Observe here, 10, 9 is the output. Okay, now observe here, very important, a very specific thing which I am going to discuss now. Okay, now observe here. If I print here hash codes of I1, if I print the hash codes of I1 and I2, SOP of I1 dot hash code, SOP of I2 dot hash code, SOP of I2 dot hash code. What will be the output? 10 comma 9. Okay, that's it. This is the output. Please observe. This hash code is different hash code. This hash code is different hash code. This hash code generating by with the help of object class native method hash code, and this output you are seeing because of object class hash code. I mean, this object is what? Integer class hash code method. I said that at earlier. What is that? Within all wrapper classes, hash code method equals method has been overridden. Now here they have overridden hash code method to return object, that is object data only. Logic to return the object data. Now what is this? I1 object data 10, so 10. Okay, now what is I2 object data? 9. That's why 10 comma 9, very specific, important. Observe here, this hash code generated because of object class hash code method, and here this 10 and 9 has been generated as an output because of this corresponding object class hash code methods. This hash code method is having logic to return object data, but whereas object class hash code method is having logic to return the integer value, which is approximate value of address. Okay, which is approximate integer value of address. Okay, approximate integer value of address. That is the logic within object class hash code, whereas in integer class hash code method is having logic to return object data. It is having logic to return object data. That's why we are going to see the output as 10 9. Very important, very specific. Okay, at the time of object creation, observe here, at the time of object creation, because of new keyword or else an operator, it can be called as an operator or it can be called as a keyword. Here memory allocation will be done because of new keyword. At that time object class hash code method will be called, which is native method having implementation purely in C language. Okay, so that method will be executing. That's why at the time of object creation different hash code, but after creating object, I'm calling hash code method of corresponding object class, getting hash code methods available within object class. So these methods will be called now. Okay, because of new keyword execution. New keyword, new is what? An operator having its own implementation internally, but here I am calling hash code method by using reference value. So here hash code method of corresponding object class method will be executing. This is having logic to return object data. So that's why 10 9 will be the output. Let me compile and execute this one. Just a minute, observe here. Okay, just a minute, observe. So let me put here, what is that? I1 dot hash code. Okay, other one is what? I2 dot hash code. So 10 9 will be twice as the output to us. Observe. Okay, I hope you understand this one. Okay, why? Because but one small thing, most of us are aware of that one, but we are skipping that one. Okay, now observe. SOP of I1 double equals to I2. Please friends, observe. This double equals operator, in the case of reference variable, it is meant for comparing what I1 is holding and what I2 is holding. Okay, holding, but not hash codes. Okay, now what is I1 value? 2a. What is I2 value? 1a. Both are same or different? What double equals operator behavior? Double equals operator behavior is what? It will return true. It will return true if operand 1 and operand 2 are same. It will return false if operand 1 and operand 2 are different. Okay, now observe here. Operand 1 is what? 2a. Operand 2 is what? 1a. Both are different. So answer is what? False. Okay, false. Now after object creation, if you check their hash codes, now they will be same. I mean, now here they are different. Okay, now here they are different because of this method, or I mean because of this instruction. So let us check this one. So it will return false to us. Okay, this double equals operator, in the case of reference variables, it is meant for what? It is meant for comparing reference variable values which are having some different values. So false will be the output. Okay, observe. So false will be the output to us as the answer. Okay, what is that? I1 double equals to I2. Okay, now here we should get answer as what? False. Observe here and run this one. Okay, false is the output here. Okay, now observe. This is what AutoBoxing, AutoUnboxing example. Okay, now observe here, as part of this AutoBoxing and AutoUnboxing, we are having one help from the JVM. We are having one help from the JVM. Okay, we are having one help from the JVM, that is, observe here, buffer with respect to the memory. We are having help. Getting with respect to the memory, we are having help, that is, instead of creating more number of duplicate objects, instead of creating duplicates at memory, we are going to reuse the same object. Okay, instead of creating duplicates, we are going to use the same object by using buffer concept. Okay, by using buffer memory concept. Okay, observe here. We are having one help from the JVM for AutoBoxing. We are having one help from JVM for AutoBoxing. Okay, observe here, what is that means? A buffer area, getting buffer memory area. Okay, for AutoBoxing, getting for AutoBoxing. Okay,